In this video, we're going to get to Chapter 2, which is apportionment. Apportionment is about finding ways of figuring out how to share things that can't be divided arbitrarily. For example, assigning government representatives to states based on population, allocating funds to schools based on student population, assigning firefighters to districts based on average number of fires each year, etc., things like that. So, let's assume that we have two schools. One school has a population of 1,000, and another school has a population of 500. If we're splitting money between the two schools, it would make sense for the school with more students to get more money because they're going to have more expenses. So we couldn't just take all of the money in the budget and divide it in half because that wouldn't be fair. So apportionment is about finding ways of allocating resources in a way that's more fair, generally based on population, but sometimes it can be based on other things. Before we get to some examples, there are some important terms we need to talk about. The first one is state population. This is the population of an individual state in the problem. Next, we have total population, which will be the sum of the population of all states in the problem. Generally, you're going to have to calculate total population. State population will be given to you in the problem. The next thing is house size. This is the number of seats for representatives or the number of things being allocated in the problem. So this is whatever's being given out. It could be representatives, it could be seats for representatives, it could be money, it could be all sorts of different things. So state population, house size will always be given to you. Total population you'll have to find. And now we have some more important terms. The first one is natural divisor. This is the total population divided by the house size. And this is something you'll have to calculate. And what the natural divisor is, it's the number of people per one representative. So maybe a state has, 356 people for every one representative they're due in, whatever system they need representatives for. The next thing you're going to have to calculate are states' natural quotas. And this is the state population divided by the natural divisor. What this means is this is the number of representatives that particular state is entitled to. And it'll be different for each state because they're all going to have different populations. And just one important thing to keep in mind is that you always round these numbers to 4 decimal places. They are usually not going to come out to be whole numbers or integers. They usually will have a lot of decimals associated with them, and you should always round them to 4 decimal places. There will be some instances later where you'll need to round to 5 decimal places, but for now, at least 4. One problem that comes up when doing these problems is that natural state quotas are rarely, if ever, whole numbers, and unfortunately, we can't cut up representatives as much as we might like to do so. So let's say a state's quota comes out to 17.6543. We would expect them to get 17 representatives, but you can't give them 0.6543 of a representative. Like, what are you going to do? Cut somebody's arm off and say, here's, this half of a representative? We can't do that with people. When you're dealing with people, you always have to be working with whole numbers. You can't say, here's half of a representative, or here's 75% of a representative. Like, what are they doing? Representing one state 75% of the time, the other state 25% of the time. Doesn't work like that. They could get 17, maybe we would round this up to 18, but it's not going to be, a perfect 17.6543 representatives. Now let's get to an example. So let's say we have 3 states with populations shown in the table below want to hold a conference, and there will be 400 representatives. First, they're asking us to find the natural divisor, then they're asking us to find the natural state quotas. Then they want us to apportion the 400 representatives by rounding, and by rounding they mean the state quotas. So let's take a look at part A now. So for our natural divisor, that is equal to the total population over the house size. So our house size is 400 representatives, the number of whatever it is that we're giving out. The total population, if we add up all of these guys, our total comes out to be 461. Now, I know this says in thousands, but it's okay if you just leave these numbers as are. You don't need to change them to thousands. It's easier if you just work with the numbers that are given to you in the problem. So our natural divisor, if we plug in our house size of 400 and our total population, we can find the natural divisor. So this will be 461 divided by 400, and that gives us a natural divisor, rounding to 4 decimal places, of 1.1525. So that's what we have for part A. Now for part B, we want to find the natural state quotas. So we're going to need to remember our natural divisor for that. So our natural state quotas are equal to the state population divided by the natural divisor. In this case, our natural divisor is equal to 1.1525. So that's equal, to the state population over that. But that's only for this problem. For other problems, you'll have a different natural divisor. So what we do is take each state population. So for Springfield, it's going to be 34 divided by our natural divisor of 1.1525. And we do that, we end up getting 29.5011, rounding to 4 decimal places. And then we would do the same thing for the other two. State population of 114 divided by our natural divisor of 1.1525 gives us a state natural quota of 98.9154. And if we have a state population of 313, we divide that by our natural divisor of 1.1525, and we get a state natural quota of 271.5835. So this is all for part B. Now part C said to allocate the 400 representatives by rounding. So what we would do is say, okay, well, the state quota for this state is 29.5, so we would expect them to get at least 29. If we round this, we'd round this up to 30. So we'll say, okay, let's give you 30 representatives. This state quota came out to 98.9, which is pretty close to 99. So if we round normally, we'll allocate you 99 seats. And then this is 271.5. If we do an allocation here by rounding, this would come up to 272. But now let's see if this adds up to 400. If we add all of these up, we get 401, so this didn't work. So we only have 400 seats to allocate, and we ended up allocating 401. What we're going to be looking at in the next couple of sections is different rules, different methods of allocating seats like this to prevent things like this from happening. So we're going to look at a number of different methods, and each of the methods we're going to look at will guarantee, okay, if you have 400 representatives, they're going to give you some series of rules for how to hand out the representatives in such a way that we don't end up going over like this, or we don't end up going under.